Hi, this is Vikas. This is the concept video about nodal analysis, which is mostly used to analyze a voltage or to find voltage across a node. Now, in nodal analysis, I'm from CSC Data Science Department, and nodal analysis is used in lots of basic techniques. Now, let's discuss about nodal analysis. Now, let's discuss what is nodes. The node voltage method is based on the following idea. Instead of solving for circuit variables I and V of each element, we solve for a different set of parameters, node voltages in this case, which automatically satisfies KVLs. As such, we don't need to write KVLs and only need to solve KCLs. In this case, what is KVL and KCLs are? KVL is Kirchhoff voltage law and KCL is Kirchhoff current law. KCL is the sum of the currents entering the junction is equal to the sum of the currents leaving the junction. And here KVL is in a closed loop, the sum of the voltages across the closed loop is zero. These two are the most important laws in laws, and we need to know about this to find node analysis to use the method node analysis. Node analysis is more commonly used than mesh or loop analysis for analyzing networks. It can be used to determine the unknown node voltage of both planar and non-planar circuit. Nodal equations are usually found by applying Kirchhoff's current law to the nodes with unknown voltage, whereas the equations based on Kirchhoff voltage. In order to apply nodal analysis to circuit, first step is to select a reference node or a datum node. Datum node is also called as a reference node, and then assign a voltage of each of the other nodes with respect to reference node. Now let's again just once revisit the nodal analysis. Nodal analysis, let's again just discuss about it. The node voltage method is based on the following idea. Instead of solving for circuit variables I and V for each element, we solve for a different set of parameters, node voltage in this case, which automatically satisfies KVLs. As such, we do not need to write KVLs and only need to solve KCLs. Nodal analysis is more commonly used than mesh or loop analysis for analyzing networks. It can be used to determine the unknown node voltage is of the both planar and non-planar circuits. Nodal equations are usually formed by applying Kirchhoff's current laws to the nodes with unknown voltage, whereas equations based on Kirchhoff voltage. Nodal analysis. In order to apply nodal analysis to any circuit, the first step is to select a reference node or datum node and then assign a voltage at each of the other nodes with respect to the reference node. Now let's discuss procedure how to find nodal analysis. After that, let's discuss about this and then sample problems. No. Procedure in node analysis. Let's talk about that. First, we need to select a reference node and treat it to be at zero or ground potential. Label the nodes with unknown voltages. At each of these nodes, mark current in the element as the flowing away from the node. From KCL equations and solve the set of simultaneous equations for the unknown voltages. Nodes. Node refer to any point on the circuit where two or more circuit elements meet. For two nodes to be different, their voltages must be different. Without any further knowledge, it is easily to establish how to find a node by using Ohm's law. V equal to IR. When looking at circuit schematics, ideal wires have a resistance of zero, since it can be assumed that there is no change in potential across any part of wire. All of the wire is in between any components in a circuit is considered part of the same node. Node. Node refers to any point on a circuit where two or more circuit elements meet. For two nodes to be different, their voltages must be different. Without any further knowledge, it is easily to establish how to find an ODU by using Ohm's law. V equal to IR. When looking at the circuit schematics, ideal wires have a resistance of zero, since it can be assumed that there is no change in the potential across any part of the wire. All of the wire in between any components in a circuit is considered to be part of same node. So this is the topic of nodes, and the previous slide is about how to solve a circuit diagram with the help of node analysis, and what is a node, and the method to solve node analysis. When we go to the next slide, there will be a simple program. Here we have three voltages. Of one is of 100 volts, another is of 80, other is of 60, and one is grounded to 0. And four resistance and node voltage VA at 8 ohm point, 6 ohm, 4 ohm, 2 ohm, and 8 ohm. Here VA is 64. Nodes with same voltage. Here we will be able to find nodes with same voltage. In this circuit diagram, the voltage in the green node is the same throughout. Likewise, the voltage in blue node and the red are same throughout. Entering versus leaving. L enter equal to L leaving. Node equation I1 plus I2 equal to I3. As you can see, I1 and I2 are entering the node and I3 is exiting the node. If we move I3 to left side of the node equation, then the node equation becomes node equation I1 plus I2 plus of minus I3 equal to 0. Here we are. From next, we'll be finding problems using node analysis. Find the here we need to find the current through R through. The figure is given like we have a 50 volt cell which is passing through resistance of 20 ohms and then 100 ohms and R3 120 ohms. R4 is of 330 ohms and another voltage is of 50 ohm 20 ohms. Now let's just draw out the circuit diagram with naming nodes and the branches are circuit shown in the figure. Like let's see here I1, I2, I3. Three currents are flowing. We have taken A as first node, B as second node, C as third node, D as fourth node, fifth, E as fifth node, and a voltage V and R2, R3, and R1, R2 are resistances. Assuming the polarity of voltages, the polarity of voltages V at node C or B, with us get 20 minus V by R4 equal to V minus 50 by R1 plus V by R2 plus V by R3 or V minus 20 by 30 plus V minus 50 plus by 20 plus V by 100 plus V by 120 equal to 0. So solving this equation, we'll be getting V. The V value is 31.818 volts. By that, we'll be getting I2 equal to V by R2, that is equal to 31.18 by 100 amp. That is equal to 0.3118 amp. That is current through R2 is equal to 311.8 milliamp. Now let's revise first problem a bit. Like why we have taken like 20 minus V by R4 is like current I equal to V by R. So we have taken two difference between two voltages. That is 20 minus V by resistance R4. R4 is the resistance. Resistance in there is a voltage difference between resistance by the resistance. That is the value by voltage difference between R1 and by the resistor plus V by R2 plus V by R3. Now let's go to the second question. The question is using node analysis Find the current through the resistor in the circuit configuration of figure 3. Here it question is like we have two current ammeters of 6 amps and 4 amps and two voltmeters of 5 volts and 2 volts, and we have four resistors and two node points 1 comma 2, and the four resistors are one is of 2 ohms, other is of 2 ohms, other is of 4 ohms, and at last the other is of 5 ohms. Naming the respective nodes of the circuit as 1 and 2 and assuming the voltages be V1 positive and V2 positive respectively at these nodes. Note the equation at nodes 1 and 2 are as follows. For node 1, V minus 5 by 3 plus V1 minus V2 by 2 plus V1 minus 2 by 5 equal to 6. Or V1 of 1 by 3 plus 1 by 2 plus 1 by 5 minus V2 by 2 minus 2 by 5 minus 5 by 3 minus 6 equal to 0. Or 31 by 30 V1 minus V2 by 2 minus 121 by 15 equal to 0. This is all about node 1. For node 2, V2 minus V1 by 2 plus V2 minus 2 by 4 equal to 4, or V2 into 1 by 2 plus 1 by 4 minus V1 by 2 minus 1 by 2 equal to 4, or 3 by 4 V2 minus V1 by 2 minus 9 by 2 equal to 0. By solving A and B, V1 equal to 15.76 volt while V2 equal to 16.51 volt. Current through 3 ohm resistor equal to V1 minus 5 by 3 equal to 15.76 minus 5 by 3 equal to 3.6 ampere. Current through 2 ohm resistor V1 minus V2 by 2 equal to 15.76 minus 16.51 by 2 equal to minus 0.375 amp. That is following from node to node. Current through 5 ohm resistor V1 minus 2 by 5 equal to 15.76 minus 2 by 5 equal to 2.76 amp. Current through 4 ohm resistor V2 minus 2 by 4 equal to 16.51 minus 2 by 4 equal to 3.63 amp. Figure 4 confirms that KCL both at nodes 1 and 2. Figure 4 confirms KCL at both 1 and 2. This is the diagram of that figure 4. 1 and 2 nodes and 2 of 4 ohm 0.375 current 3.645 current 4. That's all about nodal analysis. Thank you, one and all. Thank you. Thank you. This is Vikas. Tata. Bye bye. Thank you.